So you're going to hear me say this quite a bit during this course. I am extremely bad at digital drawing. So the drawings I'm going to make of these common parent functions may not be incredibly perfect, but you can test them out by going to desmos.com and just typing in the function. And you'll get a better idea of what they actually look like, but this should suffice for your notes. So the constant function. The constant function is a horizontal line, and it's usually notated by f of x is equal to a constant number. Let's say this time it's -2. F of x could equal 1. F of x could equal 100 million. As long as it's a number with no letter attached to it, that will be a constant function. And like I said, it's a horizontal line going infinitely in both directions. The linear function is f of x is equal to x. This means the input and the output are going to be exactly the same. So it's going to go through 1, 1, 2, 2, 3, 3, -1, 1, -4, 4, and you're going to get this kind of diagonal line going through the coordinate plane similar to this. So that's the linear function. The absolute value function looks like this. It's equal to the absolute value, and these are vertical lines of x. That vertical line is, you can find it on your keyboard by clicking Shift and then the button right above Enter on the right-hand side of your keyboard. The absolute value function looks very similar to the linear function. The inputs and outputs are going to be the same on the positive side, but your outputs are always going to be positive. So we're going to end up with something that looks kind of like a V going on until infinity. And you can see my horrible drawing skills there. But yeah, it should be a straight V, none of these curly squigglies. I just am very bad at drawing. The quadratic function is f of x is equal to x squared. And this is going to form a parabola. And I'm just going to put some guiding dots here for myself. You shouldn't have to graph these exactly at this point in the assignment, or at this point in the course, I should say. You are just going to have to identify the quadratic function. You will have to graph the absolute value function though, but that one's not too terrible to graph. This is another one where you probably can get a better representation using Desmos because I'm very bad at drawing, but it should look like a U going up until infinity. We have the cubic function, which is f of x is equal to x to the third. This is going to look kind of similar to the parabola on one side. It's going to go up like this, but then it's going to curve at 0, 0 and go down. So we get this cubic curve is what it's called. The reciprocal function, this is f of x is equal to 1 over x. This is one that you're going to have to graph, so just be careful with it and make sure that you look at this in Desmos as well as taking these notes. Excuse me. The reciprocal function is going to be 1 over whatever number we're putting in for x. So as x gets bigger, y is going to get smaller because it's going to be 1 over a gigantic number. As x gets closer to 0, y is going to get bigger because we're going to have 1 over a very small number. So the reciprocal function on the right side of the graph is going to look something like this. It's just going to get really close to the x and y axis the further away from 1, 1 it gets. And it also occurs down here, because if we put 1 over -1, we're going to get -1, -1. 1 over a very tiny number is going to get close to negative infinity. 1 over a negative very large number is going to get closer and closer to 0. So this is a fairly decent representation of what the reciprocal function looks like. Again, just remember, try typing it into Desmos, and you'll get a much clearer representation. The reciprocal function squared is very similar to the reciprocal function. So we're going to do f of x equals 1 over x squared. It's still going to start at 1, 1. It's going to get close to the x and y axes faster because it's being squared. It doesn't cross like it did in this drawing because I'm, again, terrible at drawing. But it will look very similar to what we had up here, except it's going to get closer to the axis faster. But because we're squaring, when we stick negative numbers in for x, we're going to get positive outputs. So this time, our negative numbers are going to be above the x-axis. So the reciprocal squared function looks something similar to this. The square root function. Now we've talked about functions quite a bit already. We're looking at the square root of x. So the square root of x is going to yield something that looks like this. It's going to be a half of a sideways parabola. Why wouldn't we have the other half of this parabola? Because then it wouldn't be a function. So we actually have to restrict our outputs. We only allow positive outputs when using the square root function. So that's going to be a very important one to know. This is one that you will also have to graph. The cubed root function, our final toolkit function, our final common parent function, those terms are used interchangeably, is going to be the cubed root of x. So when we take the cubed root of x, it's going to look like this. And just like with the cube root function, we're actually going to go below the x-axis. You can see we went to the left of the y-axis here. This is just the cube function on its side. Because we're not having any issues with the vertical line test here, we do not have to restrict the domain for the cubed root function. So just be sure that you're aware of what each of these functions look like. Again, be sure to graph these in Desmos to get a better representation, because you will be having to graph them in the assignment.